Welcome back to Chem 101. In this video we're going to continue talking about sig figs, and now that we know how many to record when we're measuring, let's figure out how many sig figs to include or to count when we are figuring out how many sig figs we have for calculation purposes. So let's take a number like this. So this is a small number, and let's identify what's significant about this number. Well, first off, none of these leading zeros, and I'm referring to these right here, none of these are significant. And that's because these are placeholder zeros. Well, the first zero just tells us that we have a decimal point, or tells us that we're smaller than 1. And then those next zeros just tell us how far away from the decimal point we are. So these are just placeholders, and they do not count as significant. Any non-zero number is significant. So we can see right off this number 1 all the way through basically this 1 over here. All of these numbers are significant. And that includes any internal zeros. So we do have an internal 0 here. And like I said, any number from 1 to 9, or a 0 that's in between numbers 1 through 9, are going to count as significant. So all of these would be significant. Now, what about this 0 here at the end, this trailing 0? Now, trailing zeros are significant. Trailing zeros are significant. So let's kind of just look here and see if we got everything. So leading zeros, or zeros that are before a decimal point, where there aren't any other whole numbers, are not significant. Then we have any digit between 1 and 9. These are significant. Internal zeros are significant. And then trailing zeros. These are zeros that are at the end of a number when we are to the right of a decimal place. So I'm going to show you that there are trailing zeros that aren't to the right of a decimal place, and so these wouldn't count. So let's look at some, now that you've got the rules here, let's look at some numbers and see if we can just assign how many sig figs they have. So let's take a look at some of these. So I've put some units here because I do want to talk about something specific. Anytime we're counting, now this is different from measuring. When we're measuring something, we are looking at increments, right, like miles or feet or ounces. But when we're counting something, we treat these numbers as exact. And so something that's a count actually has, well, there's two ways you can say it. It either has an infinite number of sig figs, or just an exact number. And so for 100 coins, whether we say 100 coins or 100.0 or 0.00 or 0.000, we can go out forever, which is why we can say that it has an infinite number of sig figs. So when we're counting, we don't actually refer to there being some number of sig figs. We say that it's exact, or we say that there's infinite. What about the next one? 3.030 miles. So here we have non-zero numbers, so this will count as a sig fig. Here we have a 0 that's in between two 3's, so this one will count. And here we have a 0 that's a trailing 0, but it's after a decimal point, so it's to the right of a decimal point. So every one of these digits would count. Here we have 4 sig figs. Now in this next example, we have some leading zeros. Now leading zeros don't count as sig figs, they're placeholders. So in this case, the only sig figs we have are these two 1s. So we would have 2 sig figs there. Now this other number, 5.22 times 10 to the 6, there's something special that we need to know about numbers that are in scientific notation. So this number is in scientific notation. That's what we call it when we have something times 10 to the something. So scientific notation always shows us the total number of sig figs. This is mainly a problem when you're taking a number and trying to put it into scientific notation. And I'll give you an example using this 0.011 number. So actually, let's take a look at that. So 0.011, this number right here, if we were to put that into scientific notation, we would write 1.1 times 10 to the minus 2, and in this case it's inches squared. We know that we would only put 1.1 because there's only 2 sig figs in this number. We'll put this number into scientific notation after we determine how many sig figs it has, just so that you can see how we would apply that rule. So for 5.22, 4 times 10 to the 6th, this has 4 sig figs. Every one of these digits is included. Okay, let's analyze this 6,020 ounces. It starts with a 6, that's a sig fig. We've got a 0 in between this 6 and this 2, that's an internal 0, that one counts. But what do we have here? We have an ending 0. So this trailing 0 isn't following a decimal point. It's actually before any decimal point. And so that tells us that this 0 here is not significant. So this number wouldn't have 4 sig figs in it. It would actually only have 3 sig figs. And so there are two ways that you might think we could write this in scientific notation. We could write 6.020 times 10 to the 3. But this would imply that there was 4 sig figs in this number, and when there actually isn't. There's only 3. So if we were writing this in scientific notation, we'd have to write 6.02 times 10 to the 3, in this case ounces. 6.02 because we can only use the 3 sig figs. Whenever you're writing numbers into scientific notation, you have to use the proper number of sig figs. And what we just saw is that this number right here, because of this trailing 0, only has 3 sig figs. Alright, finally, this last number here, we can see that it's got a whole bunch of 1s and 3s and other real numbers. These all count. This 0 here is an internal 0. It's in between the 6 and the 1. And we have a trailing 0. So what's the rule again? If we have a trailing 0, it has to be following a decimal point. And since this one is, it counts. So we have 1, 2, 3, 4, 5, 6, 7, 8 sig figs in this answer. Alright, so now that we know how to identify the proper number of sig figs, the next step is to use these in calculations. And there's some rules for using sig figs in calculations, and we usually break these into 2 different groups. There's the addition and subtraction rules, and the multiplying and dividing rules. So in the next video, we'll take a look at how we add and subtract numbers using proper sig figs.